Hello everyone. Our next topic is extrapolation, and extrapolation is one of the issues we run into when we want to use our least squares regression line to make predictions. So in general, we can use our linear model to make predictions about different x values, and I've cautioned everybody against using a y value to make a prediction about an x value, but in general we're safe to use x to predict y, except for the cases where perhaps that x value falls far outside of the range of the data used to form the model. So when we attempt to make these predictions with a very large x value, it's called extrapolation. And in general, if we're extrapolating, we don't really trust the value of that prediction. So when we think about a regression problem, really what we're interested in is how does y change when x changes. So as x increases, does y increase or does it decrease, and at what rate? When we start talking about extrapolation, we get into a little bit of trouble because we don't understand exactly how that model is going to change for those larger values of x. And we have one very good example that involves oil prices. So for example, if we look at this time plot involving oil prices, we start to see that if we decided to extrapolate going back to about the year 1997, 1998, we might predict that the oil prices would be increasing steadily, but at a pretty constant rate for both of those models. So for example, the blue model there is based on 1998 data. I'm sorry, the green model is based on 1998 data. The blue model is based on 1999 data. But then when we follow after that point, we see what actually happened with those oil prices. Suddenly there's this very sharp increase in oil prices. So in general, if we use the forecast models that were given in blue and green, we would dramatically underestimate the price of oil. And this is one of the issues that occur when we deal with extrapolation. So in general, we would say that extrapolation is very dangerous. Trying to attempt to peer into the future like that, we don't always find our models are terribly successful at doing that, but it doesn't seem to stop people from doing this, and that's one of the challenges. So if you do encounter a situation, whether it be on a test or an exam or even later in your professional life, where you're in a situation where you may have to extrapolate, um, you know, you can still calculate a prediction, but I would be sure to really caution any consumers of that information that the accuracy of that prediction could be very questionable without additional data.